Hello, and welcome to the Carnegie-Stout Public Library's course on 3D printing and design basics. In this video, we will cover what 3D printing is, specifically FDM printing, as well as covering the basic skills you need to find a model online or begin to design your own. To start off, what is 3D printing? Well, 3D printing is known as a form of additive manufacturing. The additive part meaning that you add something from nothing in order to create. Think of it as the reverse of sculpting. A sculptor may take a big block of marble and chip away small bits until they have their finished creation, but with 3D printing it's the opposite. You start with nothing and you slowly add bit by bit until you have your complete model. Only these little bits that 3D printers create with are not chunks of rock, but are instead thin layers of plastic, fractions of a millimeter in height, called layers. These layers are the basics of 3D printing, specifically FDM printing. What is FDM printing? FDM printing stands for Fuse Deposition Modeling, and you can kind of break that down to figure out what it means exactly. So you're taking your deposits that you're printing with and fusing them together to create your model. With this type of printing, we are fusing multiple layers of plastic to make a model. To create these layers, strands of plastic called filament are pulled through an extruder and fed into a very hot nozzle that melts the filament and extrudes it onto a print bed or a previous layer of plastic to build a model. The hot end moves along the X and Y axis, extruding plastic based on the specific coordinates of your 3D model. Then once the extruder has finished one layer of printing, it raises up on the Z axis and begins to extrude another layer of plastic on top of the previous one. A model is made of sometimes thousands of layers of plastic. It is definitely a slow process. Models only a few inches high will take a few hours to print, while larger, more detailed models will take dozens of hours to complete. So how does a 3D printer take a computer-based model file and turn it into an actual object? Well, it uses a program that is called a slicer. Slicer is the term because you take your 3D model on a computer and you slice it into the individual layers that a printer prints. There are many out there, most of them are open source and free. The one we use here is called Cura. So if we open up a model in Cura, like this one here called Adelinda, the Singing Serpent, if we pull in the model into the slicer program, we can see that it is a roughly 24-hour print and has over 1,000 layers to it. If we look closely, we can see the individual layers that make up this model. The slicer program takes the model, slices it into individual layers, and then converts it to a G-code, or the XYZ coordinates that a 3D printer can use to extrude filament where it needs to go. So what exactly does the 3D printer print with? Well, they print with different composites of plastics. Too many to name here, and more seem to be invented every day. But the most common ones you can print with would be PLA, which is often called the toy-grade filament, and it's primarily what we use here at Carnegie-Stout. It's biodegradable and it's safe to be around while it prints. Also, the prints come out very nice. They are very flexible, yet they have rigidity to them. It's an all-around very easy plastic to use. Another one, ABS, makes for stronger printed models, but it's much more difficult to print with. You often get warping or layers peeling apart. Also, it releases toxic chemicals when it's printed. We don't use it here for those reasons. You can find different varieties that have different blends mixed with regular PLA filament. Blends of wood, brass, copper, aluminum. There's even plant blends, nylon, and loads more. Again, we stick with PLA here. It's very easy to print with, the models come out looking very nice, and it's really easy to finish with sandpaper, and it paints really well. As to what's available at the Carnegie-Stout Makerspace, we have two FDM 3D printers with a print space of 298mm by 275mm by 250mm, roughly an 11-inch cubic area to print with. We also have a MakerBot 3D scanner that can digitize objects that are at least 2 inches cubed up to 8 inches cubed in size. We also have Dremel tools, acrylic paint markers that you can finish your 3D models with, as well as MacBooks and PCs to design your parts if you wish to do so inside of the library. Before we jump into design, I think it's really beneficial to see exactly what you can create with a 3D printer. Seeing what is possible and what other people have created is a great way to get inspiration for your designs. The website Thingiverse is a great resource for this. It has almost 1 million free user-generated 3D models that you can download and use for free. open up the browser and go to www.thingiverse.com/explore/popular. This section of the site is for the most popular designs, ones that have been downloaded thousands of times and printed hundreds of times. As you scroll down, you will get a sense of what is possible to make and print on a 3D printer. Now, aside from the never-ending scrolling, you can click the top button in the upper right-hand corner to get back to the navigation bar. There is a search field up there that you can type in a keyword to find designs. The best part of Thingiverse is that with a million models, when you search, you are likely to get at least a few results close to what you are looking for. For instance, if I search Pokemon, we'll see that there's 610 results. And even if I search for something like cheese, we get 299 results. It's such a large and creative community on Thingiverse that often you'll find that you don't need to design the file you're looking for, or at least not all of it. Someone else has probably already made it. I would recommend that you pause this lesson and spend a few minutes browsing Thingiverse to get a sense of what can be designed and get some inspiration for your own creations. After this, we are going to start designing with Tinkercad. Now we are going to start designing with Tinkercad. To start off with Tinkercad, open up your browser, and in the address bar type in www.tinkercad.com. This will take you to their homepage. On the upper right hand corner, you will see a blue sign up button. Click on that. Select your country and your date of birth. Enter in your email address. And agree to the terms and conditions. On the next screen, decide if you would like to receive emails from them, and click Done. You'll notice the first screen you are taken to on Tinkercad is their Learning the Moves tutorial. When you first sign up with Tinkercad, they start you on 10 lessons that will teach you how to use their program. If you're already very familiar with computers, these lessons might be a little boring for you. I would suggest you skip them by clicking the Tickercad logo in the upper left-hand corner. If you don't use computers very often, or you just want to make sure you cover every base, you can go through the lessons by following the instructions on the left side of the screen. Hit the next button and follow the instructions as they appear. When you're finished with the task, you'll see the confetti pop out. Hit Done and continue to go on to the next project. You can go through and finish all these courses to learn the basics of Tinkercad. When you are finished, click the Tickercad logo in the upper left-hand corner and continue this lesson. When you click the Tinkercad logo, it'll take you back to your home screen. This is the screen where all of your designs will be shown. Right now we don't have any, so let's click the Create New Design button. This will take you to a blank work plane. On the top left, you see a name for your file. Tinkercad gives your design a funny name by default. You can click into it and give it a proper name. First things we will do is cover the camera movements. You can change your camera view by either using your mouse or using the controls on the left-hand side of the screen. I prefer using the mouse. If you right-click with your mouse and hold it down, as you move your mouse around, you will notice that the camera changes with it. You can also use your scroll bar to zoom in and out. While holding Shift and your right mouse click button, you can drag around your center point of view. If you choose to use the left side, there is a cube that you can quickly select different points of view. You can view the top, front, bottom, back, etc. You can also click the home button to go to the home view. You can zoom in and zoom out, switch to orthographic view, or fit to view selection, which zooms in quite a bit. I would suggest you stick with the mouse option, as it offers the best controls for viewing your item. When you select your item, you will notice a light blue outline appears around your shape. This also opens up the shape dialog box. This is where you can choose whether your item is a solid or a hole, You can also control the length, the width, as well as the height. You can also directly type into the boxes to give yourself a precise measurement. Let's pull in a cylinder shape so you can see the bevel and segment size better. You can adjust the bevel of the shape as well as how many segments the bevel takes up. You can also increase the size to make your item appear more natural looking. With the cube, there are also radius controls to make your item more round. You can increase the steps that go into that. And with the pyramid shape, you can change how many sides it has. You can see that some shapes don't have any advanced features to them. You can combine multiple models together to create complex shapes. Position your models where you would like them to be by clicking and dragging, and then select more than one at a time. You can do this by either left-clicking and drawing a selection box around multiple shapes, or hold down the Shift button and left-click to select multiple shapes. When you have more than one shape selected, the group option appears. Grouping two shapes together makes them one solid shape. There are two basic types of shapes in Tinkercad: solid shapes and whole shapes. Solid shapes are just that. If you were to export this shape and send it to a 3D printer, you would get a printout much like you see. However, if we make this a whole shape, you cannot export that. Whole shapes exist to cut out from solid shapes. So let's position this shape into the middle of this one. We will left click and drag to draw a selection box around those shapes, and then group them. You can see, when you group a whole item with a solid item, it cuts out the shape of the whole. Now, if you change your mind, you could reselect the shape and notice that the ungroup icon is available. You can ungroup multiple shapes to break them down into their individual components. Now, these are just the basic shapes and the default sizes they come in. You can change these shapes by selecting one. When you click on a shape, you will see the size controls appear. The black dots you see will change your shape along one axis, whereas the white dots will change your shape along two axes at once. You will also notice a white dot up top, as well as a caret. The white dot will change your item's height, and the caret will change its position relative to the work plane. Now, if you hold Shift while you click on a dot and change it, it will change the shape uniformly. In addition to the XYZ controls, you will also see 3 angle adjusters. You can click on any one of these and drag it around to change the angle of your object. If, while you are dragging your mouse, you have it inside of the circle, your shape will snap to 15-degree increments. If you move your mouse outside the circle, you can move 1 degree at a time. You can also change multiple angles at once. If you make any mistakes, you can easily undo them by clicking the Undo button on the left-hand side. You can undo many steps of your design. While you're undoing, you have the option to redo if you change your mind. But do note that you lose your redo option if you change your model in any way. You can delete a shape by clicking on it and either hitting the delete button on your keyboard or pressing the delete. You can also quickly duplicate an item by selecting the duplicate button. Let's group a couple of shapes so we can illustrate the flip options. We're going to select these 3 shapes, select group. You'll notice now this is one solid model. Now if we wanted to, we could copy this and paste it. If we want to mirror it, we could select the rotation tool and spin it at 180 degrees. But then you notice that these are flipped around. What we want to do instead is tell it to flip. Select the flip icon, and then you can choose which axis the model is flipped on. There we go. Now you notice this is a proper mirror. Alignment is another handy tool. Let's say you want to align these two shapes. Select both of them and click on the Align button or hit the letter L. This will show you the Align dialog boxes. Mousing over any of the dots will give you a preview of what your model will look like once everything has become aligned. So if we want to make sure that they were perfectly aligned on this axis, you click the button and it lines them up. This can be particularly useful when you are writing words. In addition to the basic shapes, you can import text and with this you can also change the bevel and the segments. Aside from basic shapes, you can also pick out individual letters and numbers and symbols. Now, although Tinkercad uses basic shapes, you can create complex models by adding multiple shapes together. For example, here is a design created in Tinkercad. It is a cup holder that you can stuff between couch cushions. Here's an example of it. This was created with basic shapes in Tinkercad. Let's pull apart the model to see the basic shapes. We'll select it and click Ungroup. And let's continue ungrouping until we are at our base shapes. Here we can see that this is made up of 4 round roof sections. That cup holding part is made up of a cylinder, a cube, a cylinder hole, and a pyramid hole. When you group them all together, you get the finished model. Here's another example of a complex shape you can make with Tinkercad. This particular shape is a recreation of the end stops we used to hold our books up at the library. This is to the exact specifications of our current dividers. On the left side, you can see all the individual shapes that went into making the model. Although Tinkercad seems very basic, it is possible to create complex models with this program. For instance, here we have a multi-polygon shape created to make armor. This was created using nothing but Tinkercad's basic shapes and combining and cutting items. Another great thing about Tinkercad is it has the import ability. You can import a model that you find on Thingiverse or many other sites. Click on the import button and choose File. Once you select your model, click Import and wait for it to load. Here I have imported a rabbit file from Thingiverse. I will use this shape and combine it with some other Tinkercad shapes to create a personalized jewelry box for my niece. And there we go. You can create all sorts of complex shapes if you get a little tricky with Tinkercad. You may think many designs you see on Thingiverse must have been created in advanced design software, when in reality many of them were made right on Tinkercad. We hope you enjoy using it. And as always, come into the libraries and make your space to get more help.